let's take a look at fraction war. Now, this game is only appropriate for grade 2nd and up. So the kindergarten and first grade students will be playing a different game called Subitizing War. So this is only for the older students. 2nd and 3rd grade students will have set A. Now you'll notice when you look at set A, it's only telling you the denominator. It is naming a specific size of the pieces. For example, fifths, sixths, okay? So what we really are trying to get students to do here is we want them to reason about the number of pieces in the whole and the size of those pieces. So if they're trying to, if one partner lays down fifths and the other partner lays down sixths, students may often be tempted to think that 6 would be larger because they think 6 is larger than 5. However, we want them to think about that inverse relationship of the fact that this whole has 6, it's broken up into 6 parts, and this one is broken up into 5 equal parts. If I have less parts in my whole, each of those parts are going to be larger. So in this case, fifths is larger than sixths. So the person who laid down fifths would get to keep the cards and the game would continue. Now for the older students, they have actual cards that have numbers in fraction form. Okay, but we really again want to encourage students to use reasoning in order to compare. They can also use their whiteboard to draw models or develop equivalent fractions if they need to. However, we want to encourage them to really think to really reason about the fractions and their size. For example, let's say they are comparing 5/6 to 4/8. Let's say one student laid down 5/6, one student laid down 4/8. One way you could reason about the size of these fractions and which one's greater is by thinking 4/8, I know 4/8 is equivalent to 1/2. Well, it would take 3/6 to be equivalent to 1/2, and 5/6 is more than that. So I know 5/6 is greater than 4/8, so that student would get to keep the cards. Another example would be if they were comparing 2/3 to 7/8. It's not so easy to quickly identify a common denominator or even a common numerator between the two, although students could do that. One way they could think about this is 2/3 is one piece away from the whole, and 7/8 is only one piece away from one whole. Well, thirds are bigger than eighths, so this one only being one piece away from the whole, that's a larger gap between this fraction and being one whole than this one is. To show it to you as a picture, just to kind of give you an example, let's say I have 2 wholes. One of them is partitioned into thirds, and one is partitioned into eighths. 7/8 is only 1/8 away from one whole, as opposed to 2/3, which is a third away from one whole. Because thirds are larger, that space between the fraction and the whole is bigger. So that tells us 7/8 is the greater fraction, so the student that laid that card down would get to keep them. So while students can draw pictures, they can develop equivalent fractions, we really want to encourage their reasoning about the relative size of the fractions.